Hey everyone, we just finished up the video on basic definitions for circuits. Now we're going to actually look at some circuits here. All right, so this is just a little app I found on the FET website. So that they've got a lot of things we're going to be using. This is a great app for doing labs as well because we don't actually have to physically have the equipment to build an electric circuit at home. So here we go. I'm going to switch it so it looks like circuit symbols. From here, what I'd like you guys to do is you can pause the video. I will post a link for this as well. And what you can do is you can actually go through and learn all the different symbols in here. Okay, so we got erase. Okay. So we're going to play with different things in here. You got an eraser, a coin, a paper clip, dollar bill, just to see if those are conductive, I think is why they're in there. So the ones you want to worry about here, if we start at the top, this straight thing's a wire, battery, light bulb, resistor, switch, fuse, and you got all that. So that's just some of the symbols you need to know. I'm going to start off with the circuit. I'm going to explain a few things that are going on here. So we're going to start off with the battery. I'm going to add some wires here. Put a wire there, a wire here. Now, the first type of circuit we're going to learn about is what we call a series circuit. So series circuit, you only have one path for the electrons to flow. So we're going to put a light bulb in here. What I'm going to do is I'm just going to take the wires, join them onto the opposite sides of the light bulb. Now you can see that the electrons are flowing here through there. Oh, yes, it is showing electrons moving. Okay. So if I switch this to this, you'll actually see the light turning on and the electrons going through there. So a couple things to note here. You have wire resistivity is at tiny. You have the battery resistance is at 0, which is where we want it to be. An ideal battery does not have any resistance, but in real life, that's not actually the case. Okay, so we have this light bulb, electrons are flowing through there. Why are we getting light? Well, the metal, you can see a little wire inside the light bulb here. What's happening is if you compare the wire here to the wire here inside the light bulb, the wire inside the light bulb is extremely small. That means all those electrons are forced to go through there, and what's happening is because it's so small, the electrons are actually colliding in there, causing the wire to heat up. So because there's less room, there's more resistance. They are having collisions and things like that in there. The atoms are heating up. The wire itself heats up. And when things get hot, they emit light. So that's basically why we get the light in there. What else are we going to talk about here? So we have that. Now, this battery, it's set to 9 volts right now. So I'm going to turn the voltage down and show you what happens. What you'll notice is without even measuring the current, you can see that the electrons are going a lot slower. Now, what that means is the current is lower. There's less electrons moving through there each second. So as we put the voltage up, you will notice more electrons are flowing through there each time interval. Okay, so as voltage goes up, you should notice that more electrons are going to flow. Now, voltage is kind of a double-edged sword. What I mean by that is the bigger the voltage, the more electrons you'll have that want to flow. So voltage will push more electrons through. And the other edge of that is they'll be carrying more energy. Okay, so the bigger the voltage, the more electrons flow and the bigger the energy they're carrying. Because remember, voltage is measured in joules per coulomb. So when you have electrons flowing, they're carrying energy. So they're carrying more joules of energy as they're flowing through there. So when you increase the voltage, you're not only increasing the energy that the electrons have, but you're increasing the number of electrons that actually flow. All right, so the next thing we're going to do here, I'm just going to start a new video here, one moment.